The LP12 is a suspended isolation turntable. It's designed to minimise interference from external vibration and acoustics, getting into the signal retrieval of the stylus in the groove. We consider the LP12 in design as broadly two systems. We have a ground side and a live side. The live side of the turntable consists of every part that is suspended on that isolation system. At the heart of the turntable is the sub-chassis. It links all of the components of the live side together: the bearing and the platter, the tone arm and the cartridge. An important role of the sub-chassis is to ensure control of the geometry between the bearing and the tone arm mount. The spinning platter on which you rest your record sits on top of the bearing. Any change in the position between the bearing and the tone arm mount will affect tracking of the stylus in the groove. The sub-chassis is clearly fundamental to the performance of the LP12. KEEL SE is a super evolution of our benchmark KEEL sub-chassis. It's the most advanced sub-chassis we have ever manufactured. KEEL SE brings several improvements. We've increased the stiffness and reduced the resonance of the sub-chassis, but also we've lowered the isolation frequency and brought the centre of mass closer to the middle of the suspension system. Our first aim was to improve upon the already impressively stiff keel. Keel in its form, its general form, is pretty much dictated by the mechanics of the turntable. It has to sit on the isolation system, it has to mount the bearing and the tone arm in pretty fixed positions. So we couldn't really play too much with the geometry, but we could look more closely at where the stiffness was really important to us. So if you draw a line between the bearing and the tone arm colour, that's actually the single axis that's of most concern to you. If you have any twisting on that axis or any bending on that axis, you will directly affect the tracking of the needle in the groove. Allowing other areas of the sub-chassis to vibrate is actually quite beneficial. It means you can dissipate energy and reduce the amount of energy that exists on that axis between the bearing and the tone arm, guaranteeing that dimensional stability that you're looking for. Additional design focus was on lowering the isolation frequency of the suspension system and bringing the centre of mass closer to that midpoint. Now, the benefits of these are twofold. By reducing the isolation frequency, you let less noise into the system, be it acoustic or vibration energy coming into the system, so that obviously improves your information retrieval from the stylus in the groove. Bringing the centre of mass closer to the middle of the isolation system just means that setup will be easier, obviously, but also your suspension system will operate in a more predictable manner. So, with these design goals in mind, we set about designing the KEEL SE and more specifically running finite element analysis to design and optimise the bracing structure of the KEEL SE. To run the optimization of these simulations, we built a heuristic neural net which looked at prior results and sought ways to improve upon those results to get closer to our design targets. So quite literally, the optimization evolved within itself to produce a result that matched our desires and our expectations. Sounds simple enough, but the result that came out of the optimization was wild. It was unmanufacturable. So this was really where the hands-on engineering started. We sat down, design, and our manufacturing engineering team to look at what had come out of our heuristic optimization and decide which were the best bits, which could be manufactured. We needed to produce something that was going to be manufacturable repeatably and reliably with a high degree of accuracy. So this was real iteration on physical parts at this stage. We took the best bits of the optimization, we machined a sub-chassis, we took that away and off the machine we analysed it with a laser interferometer to check the vibration across the surface, and then we built it into an LP12 and listened to it compared to the existing keel, compared to some early other prototypes that we had. We then iterated that process. We went back and said, well, we like this bit, we want to keep this bit, but what can we do about this bit that we had to cut off before? Can we get that in a different way? And gradually, step by step, over probably 5 or 6 iterations, we arrived at what is now the KEEL SE. The final Keel SE takes the best of both disciplines. We've taken the best out of the finite element optimization, we've taken the best out of the machining capability that we have in-house, and we have produced the best sub-chassis for the LP12. Keel SE has increased stiffness in all the key areas. This pushes resonance frequencies higher and amplitudes lower, locking together the geometry of the bearing and the tone arm collar, resulting in far more accurate tracking. The design lowers the isolation frequency of the LP12 suspension system, guaranteeing that less external noise can get in to affect your vinyl playback. Furthermore, the centre of mass of the live side of the system is now better balanced over the centre of the suspension. This guarantees optimal suspension behaviour. Original Keel set a benchmark. Keel SE takes things so much further. It truly is a super evolution. Keel SE is the best sub-chassis for LP12 ever.